Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is polar form of complex numbers. The complex number could simply be considered as an ordered pair a, b in the xy plane. Then the point a, b could be further represented in polar form by an angle theta and a radius r. The angle theta is always measured counterclockwise from the positive x-axis, and theta lies between 0 and 2 pi. The radius is given by r is equal to square root of a square plus b square. And one more important thing is, we always take r is greater than or equal to 0 because the radius, which is nothing but the distance, cannot be a negative one. Am I right? Okay. Now let us see the polar form in detail. To learn the polar form, we should always remember the Euler's formula first. Okay, let me state the Euler's formula. Hope you are familiar with the graph for any complex number, the complex plane. Okay, for more details about the complex plane, you can refer one of our previous video. Okay, please have a glance over this Euler's formula. We know that the general trigonometric formula for cos is adjacent over hypotenuse. Am I right? I'm going to use the same concept here. Cos theta is adjacent over hypotenuse. Adjacent means a on the graph. Hypotenuse means the radius r. So we have got cos theta is equal to a over r. Am I right? Now you can just cross multiply this and write this in terms of a. If you cross multiply, a is equal to r times cos theta. Likewise, you can also write an expression for b using the sin theta. In trigonometry, sin theta formula is opposite over hypotenuse. Am I right? Opposite side on the graph is b and hypotenuse is radius r. Same as the previous one, you can also rewrite this in terms of b by doing the cross multiplication. So b is nothing but r times sin theta. Hope you're clear with these two terms a and b now. Okay. Z is nothing but a plus bi, the complex number. Here in the place of a and b, just substitute what we got just before. Replace a by r cos theta and b by r sin theta. Take the common factor r outside and write all the things that are left over in a parenthesis. Hope you're clear till this step. So by Euler's formula, you can just rewrite this as z is equal to r, and you can just replace this by e raised to I theta. Hope you got an idea of how we define this. Okay. The polar form of a complex number expresses a number in terms of an angle theta and the distance from the origin r. Okay. Let me take a complex number in rectangular form that is expressed as z equal to x plus yi. Let us use the same conversion formulas as we do to write the number in trigonometric form. X is nothing but r cos theta and y is r sin theta, and we know that the radius formula is a square plus b square there. Here, since we are using x and y, we can rewrite that as x square plus y square square root. Let us review these relationships using a graph. Let me show that. Please consider this graph. X-axis is real and y-axis is imaginary. This is the radius, hypotenuse side, and xy. Theta is the angle in between r and x. This is x plus yi. We use the term modulus to represent the absolute value of a complex number, or the distance from the origin to the point x, y. The modulus then is same as r, the radius in polar form. So we use theta to indicate the angle of direction, just as with polar coordinates. Okay, now substituting, we have x plus yi, replace x by r cos theta and y by r sin theta. So we will get, writing a polar form of complex number involves these conversion formulas. R cos theta, r sin theta, and square root of x square plus y square. And we are making a direct substitution. So we will get z is equal to r cos theta plus I sin theta, where r is the modulus and theta is the argument. We often use this abbreviation RCIS to represent r cos theta plus I sin theta, just to write this in short form. Hope you got an idea of the polar form of complex number. Okay, let us discuss few examples and see how to express a complex number using polar coordinates. Here is the first example. Please have a glance over this question. Express the complex number 4i using polar coordinates. Okay, here is the solution. On the complex plane, the number z equal to 4i is same as z equal to 0 plus 4i. Am I right? So writing it in polar form, we have to calculate the r first. We know the formula for r. R is nothing but square root of x square plus y square, where x is 0 here and y is equal to 4. So there should not be no confusion. That's the reason I have written 4i in the complex form term. 0 plus 4i. There is no real number. So I have just mentioned 0 there. So r is equal to 0 square plus 4 square. Therefore r is nothing but 4 here, square root of 16. Next we look at x. X is nothing but r cos theta. But that is x is 0 here. And theta is pi over 2 in polar coordinates. Am I right? The complex number 0 plus 4i can be written as, am I right? I have just written everything in terms of r cos theta plus I sin theta. In short, you can also write this as 4 cis pi over 2. Let me give you how I got pi over 2 using a graph. Z equal to 4i, right? So I am going to graph that one. Z equal to 4i will be somewhere on the vertical axis. Okay. And it is just but one rotation. So for 90 degrees, pi over 2. The angle between these two axes is pi over 2, right? So that is how I got theta equal to pi over 2. Please have a glance over this example and let me know in case if you get any query. Hope it's clear? Okay. Let us discuss few more examples. Okay, here is the next example. Z equal to negative 3 root 3 plus 3i. Find the polar form of the complex number. Okay. The point negative 3 comma root 3, 3 root 3 comma 3. This lies in the second quadrant. Am I right? And what about the radius? Radius is nothing but square root of this plus square of this. So radius would be, so this would become square root of 36, which is nothing but 6. Next, we should find b over a. So b over a is negative 1 over root 3. Am I right? Then we should find tan inverse of b over a. Tan inverse of negative 1 over square root of 3 is nothing but negative pi over 6. Am I right? We add pi to obtain the angle in the second quadrant. Okay. Step 1 is to find r. Step 2 is to find b over a. Step 3 is to find tan inverse of b over a. To obtain an angle in the second quadrant, we are just adding pi. So that will give the theta 5 pi over 6. So this can be written in the polar form now. Z is equal to r e raised to 5 pi over 6 I. R is 6 here. So 6 e raised to, that's it for this problem. So I have written everything step by step. So it will be easy for you to remember the steps and apply the same thing even for the other problems. Okay, let me take one more example and explain you step by step in the same way. Here is the next example. The points negative 6 and negative 6. Both are negative. So it will lie in the third quadrant on the graph. Okay, we found the quadrant. Now let us find the radius. Radius would be square root of squares of negative 6 plus square of negative 6. So this will give me 6 root 2. We found the quadrant and we found the radius. Next, we are supposed to find the b over a. b over a is 1 here. So tan inverse of 1 is? So tan inverse of 1 would be pi over 4 from the trigonometric ratios table or unit circle. We need an angle in third quadrant. So let us add pi to this. So theta would be pi plus pi over 4. We got r and also we got theta now. All we have to do is write the complex number in polar form. So r is 6 root 2, theta is 5 pi over 4. Hope you're clear with this example. In case if the point lies in the fourth quadrant, how will you get the theta value? Yes, you have to add 2 pi to obtain the angle theta in the fourth quadrant because theta lies in between 0 to 2 pi. Am I right? Okay. Most often though, we do not have complex numbers that give one of the special unit circle angles. So in that cases, we usually write the angle in degree form. Please consider this example negative 4 plus 2y. Radius would be square of negative 4 plus square of 2 and take the square root. That would be r is equal to square root of 20. And tan inverse of b over a would be tan inverse of negative 1 over 2. Negative 1 over 2 is nothing but negative 26.565 degrees. Here I am using degrees. In case if you are going to find this using a calculator, you have to change the degree mode on calculator. So this point lies in second quadrant. So theta, you can use the calculator directly. I'm showing this example using a calculator. Okay. So theta would be 153 plus 435 because adding 180. Okay. Hope you all know the meaning for pi. Pi is nothing but 180 degrees. Am I right? Hope you are clear with polar form of complex number now. In case if you get any query regarding this topic, kindly let me know.